Welcome to Adam Makes Beer. My name is Adam, and I'm having a blast with my friends at Rhinegeist as we brew several turns of Truth IPA, and we'll be touring their amazing facility. Today we will deep dive their automated brew deck, their malt handling, yeast harvesting, CIP skids, beer clarification, yeast handling, and packaging, both kegging and canning. A huge shout out to the entire Rhinegeist crew, but especially Cole, Ben, and Tyler for taking time out of their busy schedule to give me the behind the scenes scoop. Let's get into it. If you just want to give me first name and then title, and it can be brewer or whatever technicality.
Senior brewer, man.
Senior brewer, I love it. I love it.
Cool. Oh, we're already rolling.
Yeah, we're running.
Cool.
You're good.
I'm Tyler. I'm a senior brewer here at Rhinegeist. I think we're going to talk through
The raw material side, milling and whatnot.
Cool. So here we have 3 bulk silos that are indoor, and we run all Pilsner.
Okay.
So all raw premium pills for now. Might switch to North Star pills, but We'll see. 3 super sacks, which are about 2,000 pounds each. Right now we're just running white wheat and Munich. We have space for a third that just got installed, but hopefully for other recipes where we might have thrown in 30 bags or something, we might be coming out of a super sack now. Then we have a specialty hopper for bags that are milled.
Yep.
And then post-mill, we have a specialty hopper for any unmilled stuff.
Okay, so like flake stuff, anything not getting milled. Sweet.
Yep. So this new mill is pretty sweet. You can actually adjust the mill gap electronically. So if we want to go down there and take a look at that,
yeah,
it's
absolutely.
Cool. It will also, say you're running close to the end of a silo and you get a bunch of chaff or something, it actually has a sensor up here that will say, hey, roller, stop. I have enough. It'll work through that chaff, get it milled in, and then once that sensor's clear, it'll turn the rollers back on.
That's so awesome, man.
Our old system did not do that, and there was a lot of times getting on top of the grist case and like unclogging things. So that's pretty sweet. But
well, awesome. Well, let me get a couple of shots of that for B-roll, and then we can go down and check out whatever. Okay.
You know who's great at this is
so
Bo.
This is this whole screen.
Did you want to come out, Bo, and say hello?
It looks like the pill silos, super sacks with white wheat.
Actually, do you want to grab
the primary mill? Oh no, that would be the specialty.
Whoa, that is cute.
The main mill over here, and the ability to add flake down here. And then this is also tracking how much of this milling is actually the progress on this mill for the next.
Well, that's
batch.
for the next guy. Yeah, it's good with coffee.
You're probably going to hear me say this multiple times, but it's really cool to see the level of automation today. That's one of the things I'm very excited
I like the orange
to show
one better, dude.
So let's run downstairs and check out all the things that we're looking at on the screen.
And there's another chain disc that's carrying the milled grain to the grist case.
Okay. So this grain that we see right here that's dropping through this is already milled.
It's already milled, or our flake topper is right there.
Okay.
So the flake stuff will get carried up from like right on the other side of this, the grist case.
Yep.
Get carried up and dropped right in.
Killer.
After the mill. So.
Killer. All right, well, sweet. Let's keep rolling. This is funny. All right, so right here are like the traditional super sacks.
Yeah.
Obviously wheat, and then that's the Munich 2. You can see down here that this is where it's dropping through, hitting that chain elevator, and taking us around there. Now, what are these?
So these are our bulk silos.
Okay.
So these get filled. We have 3 of them. So as soon as one runs empty, we'll switch to the next one. Like I said, it's all pills malt. But we're getting them filled maybe every other day. Does that sound right, Benny? Every other day for a silo fill, pretty much.
And what are they made out of? Because they're not. They don't look. I mean, there's a seam on it. You know what I mean?
Yeah, it's some sort of synthetic.
Talk to a guy who manufactures bags this size, and he said to stitch that you have to be inside of it as you make it. I go, what? So it's imported from Germany. There's a company that makes it, Dauber.
That's
So
interesting.
Each one holds up to 50,000 pounds of base malt.
That's
so
wild.
You can see this one's full, silo 3 is full, silo 2 is empty, silo 1 is full. So as soon as 3 runs dry, we're going to transition to silo 1.
For sure. Okay, so then this is the mill itself. So this is all obviously hard piped in. You can see the blue line coming down here into the mill. You know, the hilarious thing is, I have a hunch that this mill is very different than some of the ones that I've worked with, but it's funny how it's all relatively the same, the same size. So is this? Are there 2 rollers in this? Are there 2 sets of rollers?
There's 4 rollers, so 2 sets.
Okay.
And then on the side there, you can see your mill gap. And like I was telling you earlier, it's electronically controlled now. So
man, that's so cool.
You can change the gap on the fly. You can change it depending on
each recipe,
what you want to mill. You can open it wide open to send specialty malt through without grinding it up at all.
And
basically, you can tune it to whatever specifications you like.
And that handles all. That is handled all up top. Oh, that's so crazy.
Yeah,
that's
brand new toy for us. So it's kind of, we're starting off very general, and we haven't really touched it. It's like from the factory, we're going off their settings, and we're getting higher extract than we would ever have.
Okay.
So it works way better than our previous mill.
Yeah.
That's sweet. So was there like adjustments? So like I'm assuming you're running like a similar mill gap that you were before, and that like you sieve that and everything?
Yeah, so we can do a grist analysis. We can pull a sample, 100 grams off of that, and send it through a series of sieves, and then calculate the proportions of each component.
Yeah, that's sweet. At no point did I think that these silos were going to be essentially some sort of fabric. That's wild.
Right, yeah.
But it is cool too. You can see sensors down on the base of that. It's going to be right in there. So that sensor is, I'm assuming for like fill level on it and everything.
Yeah, proximity sensor saying I'm full, I'm empty,
and
then it will automatically switch to the next silo based on the fill, first in, first out.
Absolutely.
And two, I don't know if it's clear, there's valves on the bottom of each of these that the computer is saying, hey, mill out of this silo. Or saying, hey.
So it looks like there's one, hard manual one right at the bottom.
Right. So there's 3 valves. There's the large closure open. Then there's a pneumatic valve that opens based off automation.
Okay.
And then there's a third knife gate where you can say, cool, I want exactly this amount of grain to fall into the conveyor.
Sure.
And you can kind of set it and forget it.
That's awesome. That's awesome. And then this right here is this. What is that?
So this is our specialty hopper.
Okay.
For flake only. So this used to be our hopper for everything. So you can imagine if you have, I don't know, what's the most we ever do? Basically a pallet of specialty that you need to load. You can imagine it might take you a while.
Yeah, why not?
But this will be, it's just flake stuff. So as you can see, it's post-mill.
Yeah, post-mill.
So this could never go in the mill, basically.
Yep.
And I'm actually going to load it because I'm here.
Okay.
So the next turn.
Yeah, go ahead.
And then if we want, we can show on the other side of that wall is where the specialty mill hopper is.
Okay. Sweet. That's wild, man.
But yeah.
I apologize for the number of times I'm going to say that's wild today. So, anyway. All right, well, sweet. Where do you want to run to next?
I don't know if you want to see the other hopper.
We can take a look at it real quick.
I'm going to load it anyway. So
okay, for sure.
See it.
And what hopper is this now?
So this is specialty, but for milled stuff.
Okay, specialty, but for milled. Okay.
As you can see, it's much larger than our old one.
Yeah.
We haven't maxed out everything we can put in this yet.
Sure.
So I'll be interested to see.
Yeah.
But yeah, not a ton of specialty in this
And this
recipe.
is just,
so
yeah, and this is just all tied through the same chain system, essentially, then.
yep. Yeah.
Awesome.
This is basically the furthest extent
Yes.
of the chain right here.
Yeah. Oh, that's awesome, man. So cool.
Yeah.
All right, so you're going ahead and pulling that mash sample. How long has that been resting at this point, ballpark?
So this is 40 minutes. It's heating up now.
Okay.
So I'll grab it at the end of mash rest.
Yep.
Just because it's pretty consistent, turn to turn.
Sure. And so how long is this mash tun process from beginning to end? So from strike water, from grain going in until that thing is empty and being able to be filled again?
I would say, so your mash in takes about a half hour. Mash rest is about 40 minutes. Mash heating is probably another half hour.
Yep.
So
yeah,
what's that? Hour 40?
Yeah.
Math.
Sweet.
Cool.
And
now I'm going to grab a kettle full sample out of kettle 2.
So funny how there's how everything's just happening. Now, as he mentioned, kettle 2. So we have kettle 1 up here, which is on a little bit different level. And it's mostly just working with the layout of the building here, because we do have, there's that beep beep right on time, man. There's that beep beep of the fork truck that is driving underneath us here. So it is the same size as the other kettle, which is boom right over here. We do have our hop dosing vessels, which we'll be using later. And we have another set of hop dosing vessels over here. All right, so there's that kettle sample.
Yeah.
Going in.
So yeah, I'm just going to chuck these in the fridge in the sensory room, and here in about an hour, I'll run the samples.
Sweet. I feel like I'm crooked. Hold on.
A little bit, maybe.
Hell, you know,
It's an old building. It could
it's
be
a
the
high
floor.
budget. No, believe me, it's my equipment. So I know you guys just went through a big automation update, and so functionally, what did that change for you up here? Because I feel like obviously on some level you were running with automation before, but how did that work out for all of you?
So functionally, I mean, it's all Browcon equipment. It does the same things. It just gives us a lot more traceability and reporting and ease of like going back through anything we want, really. One thing that's pretty cool is you click this video button and I can look at everything the screen was doing at 8 a.m.
Okay.
So I can see, you know, maybe we had a bad runoff, or we were short on the knockout volume or something. I can go into this and see exactly what was happening at what time. So it's huge for us for traceability.
That's fascinating.
Yeah. Functionally, though, most things work exactly the same.
Yep.
It's just little odds and ends. It runs a HeatX CIP after every single turn automatically. Which is awesome because we don't have to do that ourselves anymore. But I mean,
and what does that look like for you? Are you is it caustic? Is it acid?
Yeah.
Is there what's the sanitizing look there? Is that a chemical or is it heat?
Yeah, so it's running caustic right now actually on my knockout loop.
Yep.
So it'll run caustic for 30 minutes and then it's a hot water sterilization. So it'll recirc HLT water at 190 degrees for 10 minutes.
Yep.
So it is dead. Anything that's in there is dead.
Love it.
But also a new thing for us is that the brew house and the fermenters talk to each other. So, I'm knocking out my next knockout into FE29. So FE29 says wait for filling.
Yep.
So every single knockout volume is going to get recorded, and you'll actually see the level of the tank go up over time.
Also, that's the first time I've ever heard the words FV29 used.
Oh yeah.
Well,
you could hear 50 if you stay long enough. But if anyone tells you to go find FV20, they're playing a prank on you.
Okay.
Because
not a thing?
For some reason, 13 through 20 don't exist. I don't know. But
I like it.
Yeah. So.
You want to know the story? Why there's no.
Say the story.
Upstairs, they kept putting fermenters in. Then, when they started building this cellar, this became Cellar 2.
Okay.
So they left room for expansion upstairs to go up to fermenter 20. So then they started counting in the kind of programmer kind of sense where
2, 1.
I don't know why they didn't start with 20,
right? Necessarily,
but that's why there's a skip. There's a abrupt change.
Every place has to have its little quirks.
Yeah,
you know
right.
Absolutely.
It's a little funky. Just keep you on your feet.
But along with that, we had some new equipment installed. Did you talk about weak work at all?
It's not being used right now, but we have added a whole nother kind of subsystem onto the runoff. So now at the very end of, you got first wort, your strongest wort, then your sparging. So that's second wort is coming down in gravity. Then you have more extract that is bound in the spent grain that would be sent to the cows, right? So you're going to lose that, or it's going to go down the drain as effluent. Yeah. Instead, you could do another sparge of like up to 12 barrels. That's what we kind of have targeted. And then that 12 barrels would run off into a separate tank and then be used as foundation water or used as sparge water, and just recycles ad infinitum, over and over. And you don't lose it, basically. You don't pay for it to go down the drain.
Yeah.
And you can actually reduce your grain bill.
Yeah.
Use less grain because you're capturing that trailing edge of extract that would go down the drain.
That's really interesting, too. And then we talked about before, and I'll show you, there's a line that goes both to the mash tun over here, and then Whirlpool. I'm pointing to the, okay. Correct. Whirlpool over here. That has phosphoric that is piped in. So is there any acid adjustment that would go into that kind of weak wort that would be used as the foundation water?
Not at this time. It's still kind of a pilot program, so we haven't done the thorough testing that you want to do before you roll it out.
But it's obviously still all being tracked out by the mash tun.
Right. So it should be equivalent to what your mash was adjusted to. Yep. And then it's being used in the next subsequent turn.
Interesting.
So it's not sitting there and souring.
Yeah.
It could be in Germany. They have a sour tank that would just, be that function. But
Interesting.
I don't think, were there any other
upgrades?
And so we looked at this before. So this is getting closer to filling, essentially, that grist case. And is that filled now, or are we still rolling?
We're still good.
Okay.
We essentially, once you hit that light, you can put another one in.
Okay.
You got a little room. But
interesting.
This does seem to, so it's just basing this weight and this bar off of an estimation of how much the spent grain we're sending out there weighs.
Yep.
But it seems like it's pretty close because this is new.
Yeah.
Too.
Same imagery as a grist case, but that is a spent grain silo that's located out on the roof.
Okay.
And so it's taking the grain bill that we just milled or just grained out and multiplying it by 1.3 to account for it's heavier now that it's full liquid. And then it just got grained out, and then that is calculating, cool, now you have 32,000 pounds in there. So just like we have silos getting filled 3 times a week, we get spent grain picked up every day. We will fill up a 25-ton spent grain silo to be shipped off. And you want to hit each one of those spot on, those partial weights to get the right right grain bill, for the recipe.
So yeah, so just to jump back real quick, we're kind of talking about how that chain auger is essentially packed with other grain, and then how we deal with that. Now I know at Sonder what it would do is it would always run, because we had a program that it would run for the 2 super sacks and the silo, and it would run like the clean out, right? And so it would just run until it was dry, and then when we were getting close to tolerance for something, it would go through a pulse. Okay. So it would bump the valve a little bit, really? And it took some time.
Yeah.
You know what I mean? But that was kind of the safety, precautions that we had built in on that system. So yeah.
Yeah, this valve actually just shut, and the conveyor's running out right now. The chain disc, it's still milling, but we're not supplying the chain disc any longer, and we're just running out the line. So it's empty, and we hit our target weight perfectly, or we adjust it.
Sure.
Right?
Well, and I do think it's interesting, because for folks that haven't worked with that before, that's not something that you would necessarily think of. It's all that additional grain.
Put that entire pallet in there, and then I walk away, right?
Yes, and then worst case scenario, you have, because we always talk about on the small side when you're milling in, doing the grain sandwich, where it's some base malt up front, specialties in the middle, and then back to your white bread at the end.
Right.
Because, I've had plenty of people that do a stout one day and then do a light lager the next day, and it comes out darker than what they thought it would.
Yeah. One cool thing at Allagash is they have a separate hopper just for colored malt, just for their chocolate malt. So they never have that problem with triple. They never have that problem with Allagash white. It's really cool. And very complex and sophisticated, because they have many, many, many different motors driving different chain conveyors all over the place.
Yeah.
Cool Willy Wonka. And 2 mills.
For sure.
Or more.
For sure.
Maybe just 3.
Yeah. It's a cool space. And you guys blew up fast. So I worked with, I'm assuming you know Aaron Stryker.
Oh, yeah.
I worked with Stryker. So Stryker worked for me back in Michigan. So he was the last place, I was the last place he worked before he moved here.
Nice.
So yeah, so I knew him from way back. So I had one connection. I remember him coming in the office and being like, "Hey, I'm going to this place called Rhinegeist."
Yeah.
And I'm like, "Okay, I hadn't heard of it at that time, but obviously, heard of it now."
Yeah.
But yeah,
he's one of the early lead brewers. He's our production coordinator. He's making sure that these silo deliveries get here just in time and never too late. And he's doing a lot of the procurement and like a lot of the ordering.
I think he's quite good with that stuff too. That would be my guess. That seems like something that would be right down his alley.
Right.
Yeah. So you're mashing in right now? Oops.
So I mashed in. This is still this one.
Okay,
it's waiting on this to be empty.
Oh,
so
okay.
It's grained out. It's currently rinsing the false bottom.
Yep.
So filling up with a couple barrels, letting it drain out, fill up, drain. Once that's done, then this will transfer over. Vorlauf. First wort for about 20 barrels, and then we're going to mash it.
Nice.
So,
and maybe this is, maybe I always feel so foolish, but this is such a cool, it's like one of the most beautiful things in the brew house. This is always one of my favorite parts of the process. I don't know if it's because visually, like, it's the most structural thing happening. But right now, we're rinsing out this Lauter. The mash screen is being rinsed and being prepared for
just
this right over here, which is this current mash. We will get footage of all that as we go. So we'll get some transferring into the Lauter, and then mashing over here as well. This is one of the crazy things about.
So that's the last edition.
Brewing someplace where you're turning things multiple times a day is happening in an iterative way, and it's just happening over and over again. Pretty cool.
And that's just to float the grain bed on top of the screens rather than getting grain compacted in, and you'll have a worse runoff. So yeah, we should see some water coming in.
Oh yeah.
And it should just make a nice little layer right above the screens. And then in that hole right over there, the mash from right behind us will shoot in.
Oh yeah, baby. This is the best video I have ever gotten of a mash tun. One, there's a light in here.
Yeah. In case you want even more light, we can.
So yeah, really, as soon as that water hits the top of the screen, you start thumping in that mash just from right over here. So we're going to be dropping level in this. You can still see it kind of rotating a little bit.
Yeah, agitator stays on and the pump gently revs up.
That's cool.
And then it'll go right into a recirculation of the cloudy wort. Clarify that for 15 minutes, and then we'll start running off.
Love it. Love it. How long does this transfer tend to take?
I'd say about 15 to 20 minutes. It's pretty quick.
For sure. Yeah, I mean, it's thumping. It's thumping going over there.
Right.
What size is that? What size is that? That transfer line that's pushing that over. It looked pretty big.
Yeah.
Was that close to like
4 inch, maybe?
4 inch or 6? That was gonna be my guess.
Yeah, and it's actually, the system has a decoction pathway built in.
Okay.
So it could pump to and back to the lower tone from the mash.
How often are you decocting?
Never.
Yeah.
Yeah. But when the engineers were here last, they made the decoction program, so
yeah,
maybe one day. But
yeah, we did a couple of things decoction at Sonder.
Yeah.
And you had to work with the program a little bit. Right. But it is fun watching that work get darker.
Yeah. Makes for a longer day though.
Oh, for sure. Yeah. Like when we would do Bach, rather than doing double turns, we would just do the single.
Yeah.
You know.
Right.
Yeah, that's slick. Yeah, because that hauls, man. That's pretty cool.
420 barrels an hour.
Yeah.
You can actually see that this
graduates.
level's dropping in here now
To
as we're rolling this back over to the other tank.
faster, like this. You go.
All right, so we're dipping in to talk a little bit about some of the changes that's happened on the automation side and how that's affected some process things. And so we're kind of looking at a little bit of a potential stuck mash scenario.
Right.
Can you just double check that you're green real quick again? Yep, you are. Sweet.
We're in the green. So yeah, one of the biggest differences is the programming around runoffs. So we used to run on a thing called fuzzy control.
Okay.
Fuzzy logic. No one really knew how it worked. All right. It was a little more esoteric on how it worked.
Yeah.
You basically had a Lauter factor that went from 0 to 10.
Okay.
Lauter factor. I don't know what it means. So this is our new runoff programming. You have what are called polygons.
Okay.
Now, Ben might be able to tell you why it's called a polygon, but I can tell you kind of how it works.
Okay.
So we're still mash transferring right now.
Yep.
But as we get into first wort, we're going to be monitoring our differential pressure in the bed. So based on our differential pressure, you'll be having a flow rate and a rate height. Say, for instance, we're set on polygon 10 for our flow rate. If I come into polygon 10 here and open it up, you can see, based on, say I'm at 150 millimeters of mercury.
Yep.
It's going to call for 35 barrels an hour on flow. It does the same thing with your rake height. So say you're at 150 millimeters of mercury, it might be 20 millimeters of rake height.
Sure.
And then you have set points for each differential pressure.
Yes.
So from 50 to 300. So as your differential pressure goes up, it's going to slow the flow down.
Yep.
As your differential goes up, it's going to lower the rakes.
Yeah.
And what this does is these are interpolation points. So based on where you set these, it's going to figure out what flow you want.
I see. Essentially, this stuff is all supposed to be pre-programmed, and it reacts according to that.
So we're still in the process because this, I mean, we've had it 3-4 weeks at
Sure,
this point.
sure.
Still trying to dial it in. Someone might try to make their own polygon program and, you know, go a little too fast.
Yeah. How'd that work out?
And have, like, you know, maybe a 3.5 hour runoff, which isn't, you know, there's worse runoffs.
Sure.
But there's better ones too. You know, you try to make something faster and you make it slower. So, but yeah, that's how the polygons work. So you can, the easy way to do it is, in general, 1 is least aggressive to 16 most aggressive. We've been messing with 1 and 2, so ignore those. But essentially, polygon 3 would be your slowest runoff. 16 be your fastest, with your lowest rake height. And you can select these independently. So I could have, you know, polygon 7 on my rake height and 16 on my flow.
Yes.
Another thing you have is what's called a deep cut. This is saying, hey, if the differential gets above 300, stop the pump, speed up the rakes, and lower them, so you can kind of break up the bed a little bit and, you know, lower that differential before you start running off again.
Yeah.
So
I can see how something like that can kind of get away, especially when you're using it for the first time. And for me, when I was at Sonder, that was the first time that I had any sort of automated runoff flow rate and everything like that. And so just really getting comfortable with that, it's a whole different animal.
Yeah. There's,
you know what I mean? Yeah.
Like a lot of things with brewing, you're trying to balance multiple variables at the same time, right? Like, luckily with this, like, the speed of how fast the rakes are moving, that's fixed. That's 2%.
Yep.
So we don't need to worry about that. You're really just controlling your rake height and your flow rate.
So a question I have is, because so many pub systems they kind of have, I don't know, everything is very vertical, right? So they're taller than they are wide, and this is wider than it is tall. So do you find differences? Because obviously you guys turn a ton of Cincy Light, and so that grain bed is going to be more shallow compared to Truth today, which I'm assuming is significantly larger grain-wise. Is there an efficiency difference that you see between those
in terms of time?
No, as far as sugar extraction.
Yeah, I mean, Nick could probably tell you. We ran that weak wort recovery we were talking about. So it's you know, you're seeing what your gravity is at the end of runoff, and it was less than a degree Plato. So we took every single thing out of that.
Sure.
And I don't know, Ben, if you recall what our weak wort was. Might have been like 8 Plato that we got off of Truth.
Okay.
So you're talking about, there's still a lot left in there.
Sure.
And again, like, your bed depth is a factor in that. And just, you know, you would have to sparge forever to get all of the sugar out of that grain.
Sure.
But yeah,
I would assume that efficiency still jumps when you're doing those smaller beers compared to the larger.
It's going to be a smoother runoff. It's going to be quicker, because there's less distance that the sparge water needs to travel, essentially. So I think Truth might be like 17-inch bed depth, whereas like Cincy Light is maybe 10 or something like that. But it's manufactured, I believe, to make, you know, ideally, like, this is a German brew house and they're making Helles lagers and they're 13 Plato. So we're kind of really throwing as much as we can at it. And so we're losing in that efficiency, which kind of makes sense to get the weak wort. But it's more efficient than a mash Lauter combination, and less efficient than a mash filter, right? So it's somewhere in between, and, you know, to kind of inch closer and closer with that efficiency, we're adding more vessels.
Yeah, that's interesting. Yeah, and especially with these German systems, it seems like on some level, for servicing the American market, they needed to make probably some adjustments for what we're doing with hops and whatnot.
Yeah, we have the Hopback. I asked the Germans, "Hey, what do you know about it?" And they go, "Well, it's a prototype. You know, there's like 8, you know, in the world."
Is that whole cone that goes in there for Hopback, or is it pellet with a?
So traditionally it would be made for a whole cone, but this is manufactured for pellet.
For pellet.
Yeah.
Interesting.
So if we were to open that up, you'd see a wedge wire kind of colander tube inside of a shell, right?
Yep.
And the liquid is going to filter through, the wort is going to filter through that wedge wire and hold back all the vegetable hop material, even from pellets.
Yep.
So you're going to get better efficiency. You know, they try to sell you on, you're going to get more volume, you're going to lose less hops, and you're going to get better aroma. So
you're going to be better looking.
Yeah, right. Yeah. Probably not all three today, right now, but it has improved the size of the true vial, so you're losing less work to the true vial because you have that dedicated vessel. Yeah. So it's great in that way.
Definitely.
I am about to load the Hopback.
Yeah.
If you want to get
I would love that.
footage of it.
I would love that.
Do a little flourish with the. You want to pour the hops in?
Yeah.
You got super slow mo on that.
We'll get it all in the edit. You know what I mean? All right. So you're busting into the Hopback right now.
Yep. Basically, giant, tall stainless tube.
Sure.
That has screens all around it. So essentially, what we're going to do is pour would be our Whirlpool hops in here. And during knockout, this will actually fill up with wort.
Sure.
And recirc those hops for 15 minutes, and then open it up, drain it out through the heat X, and into the fermenter. So,
for sure. And so, is this the wort input right here? This kind of notched out.
It'll actually fill from the bottom.
Okay.
And then that pipe you see right there, that's actually the recirc. So that's the top of the recirc.
Okay.
And later, once you see it fill up, you can peer in the top sight glass and see it all moving around. But it has a spray ball in it to clean itself out afterwards. But yeah, so we're just going to throw in what would be our Whirlpool hops.
Okay.
In here.
Okay, so you're using this as what you would generally kind of see as your Whirlpool hop then.
Right, yeah.
Okay.
Not like a traditional Hopback that is like a filter.
Sure.
Or like a clarifier that also adds flavor.
And what do we have going in on that? What are the varietals going in?
So we have Centennial, Simcoe, and Citra.
Nice.
Hopback, yeah.
Nice.
So yeah, West Coast.
So
IPA,
then just
man.
spinning those shut. That was cool. That screen is really. It doesn't look like something that's removable. It looks like it's kind of built right into the system.
Yeah. So cleaning is very important on this thing. You'll notice like a huge loss in your knockout volume if those screens are not cleaned properly.
That makes sense.
Another advantage of the new programming is that it has an automatic CIP program for the Hopback. So there's no excuse that it's not cleaned any. So yeah, so I just turned a key to say, hey, no one's in there.
Okay.
Now I'm going to say, hey, there's hops in there. And it's loaded for our next knockout.
Sweet.
And we're on
that's interesting.
heat X CIP. Or sterilized right now.
It's rinsing. The conductivity was too low, so CIP took a little longer.
So before every knockout, we're doing like a very rigorous CIP on the heat exchanger and wort web, caustic clean, and then it will rinse caustic, and then it will sterilize at 190 degrees. Then we'll be ready to knock out as soon as we cast out.
Yeah, so Sonder was the first time that I worked at a place that had a sterile loop, and it's interesting because it changes the way you think about what you can be doing, especially when you lean so heavily on chemical sanitation, right? And it is actually, it's a very accessible way for people on the pub side to be tightening up some procedures that might not be natively tight based on the type of equipment they had. So he had they had a hot liquor tank that was just the sterile loop, circed at, I think it was 85C, 185F, and it was just built throughout the thing. So there was multiple ports. So there would be an in and out loop, so you could just burn out, transfer lines, adjunct kegs, different. Very cool.
Yeah.
Very cool.
Pushing with liquid is where it's at, man.
Yeah.
Whether you'll see in the cellar. I mean, I can't even imagine our cellar without deaerated water.
Right.
In terms of the Decanter or the Centrifuge, once the transfer's done,
Yeah,
the entire line
loss,
is
would be
packed.
huge.
Like, and that's just not feasible to push with CO2 or anything. So, yeah.
I went over to Brewdog. This is shortly after Saucy bought Cartridge, and they were doing a collab with them, and it was crazy that and I'm assuming that there are some similar things, but you just walk down hallways and it's just process piping after process piping, and when you're not used to that, you're like, holy crap. And then because you don't even think about when you're on the small side, you can chase some water back through, a knockout line or something like that. But in a scenario like this, you really need to have those utilities in order to carry those things out.
Right.
I mean, we'll even knock out into our other cellar from the system, and that's, might be a fifth of your knockout volume is just in the line.
Exactly.
So you have to be able to press that out, or it's like doesn't make sense.
Yeah, for sure.
Or like doing a centrifuge spin downstairs to the centrifuge and then back upstairs to the cellar. You might just run dry in the fermenter as you're receiving it.
Sure.
So it's a lot.
Interesting.
A lot of savings.
And so we're going to start hitting up the hop dose right now? Or are we going to a mashing?
So we're going to load our hop dosers first. So we're running off into this kettle, and that's typically when we'll go ahead and get our hops loaded in so that once boil starts, it's ready to dose.
Sure.
So in general, both kettles have 3 hop dosers. The first hop doser is your 60-minute, 10-minute, 5-minute.
Yep.
So for Truth, we use Phosphoric for our bittering. So I'm going to just measure out 1,500.
That measuring vessel is the stickiest thing on planet Earth, correct?
Yeah. Oh, yeah.
Yeah.
Yeah. Isopropyl alcohol is your friend.
So I've not used that in particular. That seems to flow really well. I've used some denser.
So I've
denser ones. That one seems to flow pretty well, though.
Yeah. So we like to throw it on the manway of the kettle or something to get it, a little more viscous.
So that's a little bit
Less
warm
viscous.
right now, right?
Yeah. So
drop the viscosity. Yeah. So it would be a little thicker had you not warmed
correct.
that up.
Yeah, it's a little more chunky. Cool. So I'm just measuring out 1,500.
It's a big graduated cylinder.
I know.
What's the volume on?
It goes to 2,000.
Does it go?
So
cool.
We're at 1.5. So we actually have a button that breaks the vacuum. So these hop dosers, they're getting hot, they're getting cold. It'll actually open a vent so that you can physically open it.
Okay. So can they take both pellet and liquid?
So we have a 60-minute and a 10-minute in this particular beer.
For sure.
So I will load up our Flex in this one.
And then it just has like a little hat inside of it, right? Like the little, the little dish or what have you.
Look in this one before I load it up. But, I was just talking to Ben the other day about how this exactly works.
Uh-huh.
And I don't know. So
when they go in,
I know when,
load,
I know when, and I know how.
Okay, so that's interesting. So you can actually do pellet on one side, liquid on the other.
Yep.
Pretty cool.
And this is about as high of a weight as we want to go in a hop doser.
Okay. How much was this dropped in there, ballpark?
15-ish.
Okay. 15 pounds?
16? 16 and a half. Man, I told you this guy was good.
Hey, listen, he's the real deal.
He's the real deal.
He's the real deal.
Cool. So then we're loaded. I'm just going to seal them back up.
And then it looks like probably wort is just flushing through the top portion of that and then rinsing that through.
So yeah, we've got all our valves down here. Mm-hmm. But essentially, you're shooting wort in, and also it has a pathway back into the kettle.
Yep.
And then the pump will the kettle pump will actually empty it, and we can see that all on the screen.
Nice.
Cool. So that's loaded. And now all we have to do for the program side is to acknowledge the hop doser and say, hey, these are actually loaded. So we just hit OK, OK. And you get a little Slimer emoji on there. And cool, that's loaded. While that was happening, we got really close to when it's time to mash in. So I'm just going to go ahead and mash in.
Sweet.
All I have to do for that is say, are you ready to mash in? Yes.
That's crazy.
Cool. So he's weighing out our salts. This gets 5.9 pounds of gypsum. And then I'll show you our Phos doser. So here I can select which kettle I want to go to, or which vessel, rather. Mm-hmm. In this case, I want to go to the mash, and I want to add 16 liters. That worked out for me well last time, so I'm just going to run it back. And so I'll wait till it's building the foundation water, which is happening right now. Mm-hmm. Just hit start, and it's got a flow meter. It's going to measure out 16 liters for me.
So crazy.
This was the best thing ever. We used to just have a big jug of Phos up here that you had to constantly like fill up. So
well, especially at 16 liters. You know what I mean?
Yeah.
That's not a small volume.
This is like a 1 to 4 dilution, though. Okay. So it's like 25% phosphoric.
For sure.
Just to get it to flow a little more. Cool. So it's building out about 4 barrels of foundation water, okay. And then the hydrator will start turning on.
Sweet. Wiggle, wiggle. Let's see here. Oh, yeah. All that foundation water pushing up through the bottom. Mixer going. You can see that as these side plates.
We're filling, baby.
As well, that will help with the mixing. You can hear that chain. The chain that will be bringing the grist over, and we're going to get this mashing running. And also, when I am flat out in your way, just say, hey man, you're in my way.
The camera loves it.
Okay.
That's what I've noticed.
It's a hydrator right here. Maybe it's the small thing, but the big sight glass hydrator is always awesome. It's a cool visual.
It's
fun.
Yeah, so it's there's a mixing valve downstairs that's fluctuating or articulating to get us 146 degree water.
Yeah. Very cool. This mashing borderline or baseline or generally takes how long?
I'd say it takes about half hour to mash in.
Nice.
Yeah.
Yeah. This is interesting. I'm gonna try to get the grist hydrator going right over my shoulder. So it's always interesting getting into different places because every production space is so fundamentally different. You end up finding out ultimately what you're going to end up shooting, and really today what we're looking at is almost kind of a process and equipment episode here. And I think there can be a lot of value whether you're working in the pub side, on a larger production side, and even making beer at home. It's interesting to watch the brewers on shift. They're monitoring. They are they're not hands-on with ingredients in the same way that you are in more in more manual breweries, but there's a lot of process points that they have to maintain. So anyways, very cool. And we are going to keep tracking the process as we go. Let's get back to this mash-in. Maybe not. Maybe we'll get on to something else. But anyways.
Yeah, so this is Brewer's Compass. It's a blend of 3 alpha amylase, beta-glucanase, and I believe pectinase.
Okay.
Maybe. Don't quote. But
sure.
Yeah, a blend of 3.
And who's that? Do you know who that's from? If you don't, it's no big deal.
I don't. I know Carrie makes one.
Yep.
Bro.
Is it something that has been part of the process for a long time, or is it a newer addition?
So we were having, malt issues
Sure.
for a little bit, and it's helped a lot with just consistency from runoffs, extracts, and all that. So we pretty much kept it, but the amount might vary based on the kind of malt we're
Sure.
getting in.
Sure.
But it's been pretty consistent through almost
Nice.
every batch.
Nice.
Has some sort of enzyme addition. Yeah.
Awesome.
So right now, we are running off into kettle 1, and you can see it recirculating through the internal calandria. That circular plate is you can remove that to inspect. So right now it's obviously closed. You got wort coming up through the fire tubes inside the calandria and keeping it warm. So right when we hit kettle full, we'll go right into a boil and a hop dose.
Sure. So that turbulence that you see at the bottom, that's just wort being pumped in? That's not anything boiling at that stage, right?
Right. That is an effect that's coming from the pump and the recirculation.
Okay.
But the pump that is at the wort kettle, not the wort being run off.
Sure.
Right. That's
Sure.
a slow, nice,
Sure.
gradual.
Yeah.
Runoff.
Because otherwise I was like, holy.
Yeah. We're not pumping that fast. This is going to be, minimum a 90-minute runoff.
Yeah. Okay. So that turbulence is actually a pump on kettle side.
Right.
That's driving that through the calandria.
Right.
And then just kind of in a nutshell for somebody that wouldn't know, what is a calandria? What does it kind of do?
So if you think about a boiler, right? A boiler is going to change the phase of the water and convey that temperature, convey that efficiency of steam to heat up your kettle. Well, inside our individual kettle, it's got kind of a mini boiler inside there. Mm-hmm. So it's got these things called fire tubes where it's drawing the wort upwards in a thermosiphon kind of effect, and it's coming in contact with the steam from the boiler.
Yeah.
So it's a more efficient heating process even than direct fire,
Sure.
even than steam jackets. It's a boiler inside of a kettle. Right?
Absolutely. So one thing that might be kind of a super geek question, but I'm assuming that is something that you really need to clean on the CIP side, because that's going to junk up in a hurry.
Yeah. So we're doing midweek CIPs because as you boil, you're going to get protein coming out of solution.
Yeah.
That hot tube flocculating out, and that's going to cling to the internal calandria, and it's going to foul up. So there are spray balls installed, and after maybe 20 turns, we're going to do a CIP,
Sure.
a hot caustic.
Sure.
And knock all that out and make sure that it's not fouling up and you lose that efficiency.
Do you need to have any sort of oxidizing agent that's added with that as well in order to knock that junk out?
In the past, we've used a product, hydrogen peroxide, like a really amped up hydrogen peroxide, maybe 70%.
Yeah.
And you can throw that in at the beginning. There's going to be a acid cracking kind of reaction where the caustic and the hydrogen peroxide react. It's going to be an oxidizing reaction, and it's going to knock all the protein off of the calandria pretty quickly. So we've done that. Recently, we've changed to just a hotter, a stronger caustic, and we've removed the oxidizing.
Oh, beautiful.
And so you're buying less chemicals, and you're using less product overall, and it works.
It's an efficiency thing. Yeah, definitely. Awesome.
We're true breasting. You can see some protein kind of floating there. You can see the kettle fining. There's a true pile, massive true pile beneath that liquid level, and we're gonna start knocking out.
Nice.
So that's
so that's the whirlpool.
That's the whirlpool.
Yep.
Yeah.
And how long is that? So how long does it take to fill it? In just ballpark even, and then how long to knock it out?
Yeah, exactly. It's going to take 7 minutes. Not a ballpark. Yeah, we're going to pump in. We're going to pump into the whirlpool on a tangent right here, and it's going to do exactly what it says. It's going to whirlpool, and the solids are going to collect in the center, build a nice tight true pile. That's like I said, 7-minute kind of process because we're pumping it at 650 barrels per hour.
Yeah.
So we want to get a nice tight true pile, And then it's going to rest for 25 minutes, 20 to 25 minutes. Let the kettle fining sedimentation occur for any more polyphenols, proteins collect in the true pile. If we were throwing hops in the whirlpool, we would have done that. We're adding zinc for yeast nutrient in there, and after the true breast is complete, we start knocking out. That is going to be starting right now. Tyler's doing that in the cellar, and that's going to be like a 45-minute process.
Awesome. All right, so let's take a look. We are underneath the brew house here. If you can tell me about this little tank, because it looks like it can take some pressure. Am I wrong? Or
I'm not sure the original usage of it. We got it for little to no money at an auction.
Love it.
And we repurposed it to take bulk phosphoric acid, that's 70% concentration.
Yep.
Bring it in here and mix it with a known amount of water.
Yep.
And bring it to 146 millisiemens per centimeter conductivity kind of unit right there. And then it's got some PLC programming, and it will dose directly into the mash or the whirlpool, depending on which vessel you choose to acidify your mash, get the pH perfect, or fix the pH before you transfer it.
So this was this base tank that we were talking about before.
Right. So it's got a pump
for the whole thing.
It's able to mix in the concentrated phosphoric down to what Tyler said was like a quarter concentration.
Sure. Much nicer to work with than a big blue tub that you pump.
Right.
So yeah.
Yeah, which is located right over there. Isolated and super concentrated.
Yep.
And we have to before pump it into a vessel. You're carrying that upstairs, and it's like super heavy, super concentrated. Kind of weighed like 70 pounds just for 15 gallons of it. So that's to kind of save your back, right?
Awesome.
Yeah.
All right. Well, cool. We can keep rolling. Cool. Where are we heading to right now? Over to the CIP stuff?
Well, we're right underneath the whirlpool. So this is our 2-stage heat exchanger.
Okay.
The first side is municipal water, and then it's trimmed with cold liquor water to get us down to 68 degrees or 55 degrees for our lagers.
Yeah.
So this is an upgrade off the basic kind of model, and the old model used to be here in the middle of the knockout skid, and this larger form factor, so we shoved it over there, tied it in. It's a tube filter. This is the aeration or oxygenation, depending on air's getting injected into the cold wort line.
Yeah, and so we are actually talking air here, correct, and not bottled O2, correct?
Right, exactly.
Is this the first manual valve that I've seen in the place?
Yeah, never been touched either. But this is that Christmas tree of valves. That can send you for a loop if you have any problems. And we got this nice array. This affords us the chance to clean the heat exchanger forwards and backwards on the fly pretty quickly without moving any hoses in the cellar. That's very nice.
Absolutely. And so, as mentioned before, HeatX gets cleaned forward and backwards every time.
Yeah,
between every
knockout, it gets caustic, then it gets rinsed, then it gets a sterilization, and it'll go backwards and forwards.
Love it.
Yeah, it's really great.
Very cool.
So then from there, we're passing the hot liquor tank, which is probably the largest vessel in the whole building.
How big is it?
It's about 300 barrels.
Hey-oh.
Yeah, I think right here on the maybe.
I almost tipped over.
Yeah. Don't fall. Yeah, we're gonna carefully make our way into the cellar. Right. This is the first CIP cart skid, I guess you'd call it. Each vessel's 20 barrels, and so working volume. There's about 18 barrels of high strength caustic in there, and that's pretty much devoted to just cleaning the brew house and just doing the sterilization before knocking out. The first tank's caustic, second tank is acid, third tank will recover rinse water to be used again before it goes down the drain. And then along with this skid, along with these 3 tanks, you get all the accoutrement. You got steam coming in, and you got a really heavy duty pump that can get liquid from A to B.
Sure.
So
That's wild. Okay, so this is Skid 1.
Yeah, Skid 1. So we were really bottlenecked in the cellar when we only had one CIP skid. Now we got another one at another auction. It was actually the really big brewery shut down on the East Coast.
Sure.
Got that at auction, and that's a multi-circuit skid. So we're able to clean 2 different items, components, process lines in the cellar on 2 different circuits at the same time.
Awesome.
Or tanks.
Awesome.
And centrifuge. So this one really dedicated to the brew house right now.
Just the hot side.
And before it was like you were constantly running the CIP skid to make sure that you're always cleaning something, and it made it really tough. So
for sure.
To our first kind of fermentation bay, we'll walk you through each one, but this would be the panel that is going to connect the hot side to the cellar. So say we were going to knock out from the BrowCon into FE23, the last kind of 10 feet or 30 feet, whatever it is, it's going to be a soft connection where we'll hook up a hose there to a block and bleed with a sight glass on it, and then press go and we start knocking out.
For sure. And so that whole wort line, that whole tree is run all the way basically through like the second floor and then runs down.
Right.
And
yeah,
then
it drops into the cellar, right?
Interesting. So they're all labeled up.
Right. Skipping all the other ones are...
Why does it say soy sauce CIP return?
Okay, so we also have we have 3 CIP skids. Soy sauce was bought used from a Kikkoman facility. So when we installed it, we just go, yeah, it's a soy sauce.
I love it. I love it.
Kind of forgot about that. But yeah, nicely labeled, just in case we're not manufacturing any soy sauce here.
Sure.
Ever.
Oh, that's fantastic.
Yeah,
very cool.
But
so you have multiple drops like this.
Yeah, so this is one of 4 panels, and it's on both sides. So in the center, it tees off and goes both directions.
Okay.
So right now, this is the west side of the cellar.
And we were looking at the computer before, and they all kind of have like these 3 little, the 3 big fermenters in this space, right?
So FE21, 22, 23, then 24, 25, 26. So that's kind of like, cylindro-conical fermenters are great. They're holding a ton of volume, and they've got the perfect point where you can pitch cone to cone. But if we put them all in a line in the same space, we would be having a lot of open area that's not utilized. So this is like kind of the best fitment of the space that we have to use.
Yeah, and so there's another side to this. There's another side
if we go around to the right. And then each drop, so this is kind of like a highway. It's like a avenue and a street, right? So if you go down the avenue all the way, there's a blocking valve up there. So you actually need to acquire the drop by coming to the HMI and telling that valve that's up in the air, that pneumatic valve, to actuate or not. So if I request it and apply that change, you'll hear the pneumatic valve open and close. And so all these ones that are yellow are being utilized at a different panel. So you can't I can't acquire this at this one, for example. So a little bit of automation, but it's really, the cellar is the most manual part of this whole brewery. So it's just a little tiny bit of automation to tie it together. Right?
Yeah.
So it's not fully matrix. There isn't one wort way for every fermenter. You're tying it into the panel.
For sure.
Make it happen. So we're coming up on the bright bay.
Okay.
And you can see there's a lot of hoses hooked up. It's about to be a little bit of a little nest situation on the ground. So we're going to carefully walk through here.
For sure.
All these hoses happen to be the same color, so it's not going to be easy to follow exactly, but we got Bright Tank 6. It's being packaged right now.
Okay.
So it's coming out, just sight glass, make sure you don't run dry. Then it's tethered to these filler cellar side pumps that are delivering it to the packaging hall.
Okay.
So we kind of tucked them away back there
So there's actual pumps that are driving that beer to the cellaring space.
Right.
Okay.
But eventually it's going to either CFT Supply, which is the company that makes our canning line CFT,
Okay.
or we're going to the Lambricks, the keg line.
Yep.
So they're going to go out here, they're going to go up, and then you trace them back, and they go way over to the other hall. Pumps are located right over there.
Okay.
So they're also, I guess, filling off of Bright Tank 11. And then that setup down there, Bright Tank 10 or 12, is going to receive the most recently filtered beer, which is about to happen. I can hear them queuing up the centrifuge right now, spooling up. So right now, this is the rest of the fermenter, the rest of the tank farm.
Yep.
There's 30 240 barrel fermenters down here, all kind of planted as best we could fit them.
Sure.
We just passed panel 2, the drop, panel 3 is behind us, and then panel 4. So you're never like further than 30 feet of hose away from
For sure.
what you're trying to move or convey or clean.
All right. Is there anything else that we should be looking at in the cellar? Or should we roll on somewhere else?
Yeah, filtration kind of side is right over here.
Okay.
And so we can get as complicated as you want, but you can hear it spooling up. It's going to be spinning at like 5,400 RPM. And the whole idea is the conical fermenter is just sedimentation is occurring, right? All the solids drop out and they collect in the cone, whether that's yeast or whether it's the dry hop that you put in there. And we want to filter that out and get the most yield that we can. So we have two different types of fermenters. This is a disc stack separator.
Okay.
So it's got a big conical also, or what's the word I'm looking for? Let's go look at it. Cyclonic looking bowl right here. And so this bowl is receiving liquid product coming in, and then it's doing a very polishing type of centrifugation where the density of the solid coming, you don't think of beer as having solids in it maybe, right? But there's proteins and polyphenols that can create haze. So we want the clearest beer we can make, right? So the density of a protein is actually very, very close to the density of the liquid. It's kind of difficult to separate them without a sophisticated machine. But we got this big cyclone, liquid coming in, and then a bunch of stacked discs. And those discs have a very small gap in them. And the more discs you have in there, the more you can separate this like really close density solid away from the liquid. It's spinning very, very quickly. So it's centrifugal force
Yep.
is pushing those solids to the exterior. They're collecting, and then periodically, based on turbidity or based on time, it's going to flush that and send the solids down a high-strength waste port that is side stream and doesn't go down the sewer system. It's captured in a high-strength waste vessel in the basement, therefore cleaning up all the effluent leaving the building and not spiking the municipal sewer district with, total suspended solids, biological oxygen demand, and other not so great items for the sewer district.
Absolutely.
So basically there's a drive in there and there's a hydrohermetic seal, because the whole name of the game is it's got to actually be very clear before it reaches here, because this is the polishing centrifugation. So the main issue is you don't want to pick up dissolved oxygen and you want clear beer coming out, so those are the real things that we're looking for, that and turbidity out.
Yeah. That's interesting that you say that it's like a polished stuff.
Yeah. So the alternative, like this can handle particle sizes that range from 1 micron to like 500 microns. And the amount of solids, so you couldn't take the yeast cake at the bottom of the tank and send it into here and just say it's going to be great, or the hops, and it's going to be fine, because it can really only handle 5-ish% solids in the liquid that you're sending. So that's not a lot. The alternative is the decanter can handle 90% solids.
Okay, wow.
So coming up on another CIP skid.
Yep.
So mind yourself. So now this centrifuge, we're not seeing that cyclone looking shape anymore. We have a long bowl, and inside this bowl, it can hold, you know, a couple barrels, maybe 8 barrels even. But inside of that, this is the housing on the outside. The bowl is on the inside, and the bowl has a conveyor inside of it. And so up to 90% solids coming in, it can process and separate. Basically comes out the consistency of like peanut butter.
Yeah.
Like, it's insanely good at separating really, really large solids. Like
for
hot
2 seconds,
material.
I thought you were going to say it tastes extremely good. Because
Yeah,
you just said peanut butter, and I'm like, wait.
Yeah.
So the question is, can you put like, can you just drop the entire bottom of a tank through this?
Yeah.
Is that the idea?
Yeah. So this is best bang for our buck on recovering a really, really large dry hop quantity kind of beer. So for Truth, we're putting in, you know, hundreds of pounds of hops in the cellar, and this will separate it, and you get almost virtually no loss.
Sure.
It's pretty cool piece of kit.
Absolutely. So this is like phase 1.
Yeah. So
and then we would go from this to the centrifuge.
Right. And
interesting.
Then, yeah. So this is a
you
rough.
You can keep talking. I'm just going to walk around it to see more of it. But
yeah,
keep
rough,
going.
coarse filtration that's separating solids from liquid, where the densities are very far apart, right?
Sure.
And when it is running, it's louder than a prop plane. Basically, it's very loud. So something to consider, and be thankful it's not actually going full steam. So actually,
what is there like this chute down here? What is that?
Yeah, that's a sight glass, so you can see the solids drop out in real time.
Oh, really?
And the solids are so dry that you need a progressive cavity pump attached to it to actually send them down the drain to that side streaming high strength waste tank we have in the basement. And to convey them, we actually have to add water back to it.
No kidding.
To get it to move, yeah.
Interesting.
So in an ideal world, maybe the chute goes directly down. But for beer, again, we're really concerned with dissolved oxygen. So this is blanketed with CO2. So it has to be a closed system. So you can't just have it drop out of the bottom because you would pick up a bunch of oxygen. So really cool piece of equipment and a game changer in our cellar. But not like a ubiquitous beer, like you don't see it in every brewery. Whereas a disc stack separator, you know, they're more frequently.
Sure.
You know, you'll see them all over the place. So this is coarse and rough filtration. Filtration is not even the right word. Centrifugation, right? Because sedimentation is happening in the fermenter at 1G. What this machine is doing is just spinning faster than anything. And amplifying the G-force. So it'd be like the equivalent of a tank sitting for 3,000 days, right? It's amplifying the G, right?
Yeah.
G-forces to separate those solids from the liquid.
Interesting.
State. Yeah, that's all I got.
That works, man.
Yeah. It's got this, basically the conveyor inside of it acts like a bulldozer. So the liquid is coming in and out of that side, and the solids are being conveyed like a bulldozer corkscrew. That corkscrew spins just a little bit faster than the whole bowl, and so that means it's like the conical screw in there is just bulldozing it to this port out here, and dropping out. So something to see if
that's fascinating
when it's running, because we've had to remove this to check the water and kind of get a sample, and you go, wow, it's dry. It sounds like I'm going to mess it up because I only know brewer's math, but 1 liter of water at 1G weighs 1 kilogram. But in this machine, it would weigh several orders of magnitude more, like many tons, right? So when the actual solids hit the outside of the bowl inside the housing, it sounds like gravel hitting, like burning out, and you're, kicking gravel all over the place. It's crazy loud.
Yeah.
It's amazing.
Do you actually have to rouse that cone before you put it through?
Yeah, we try not to. We try to, basically the dry hop is going to be like a 5-hour process where we're recirculating it through the fermenter. Push the dry hop in, it gets a test with the sensory team to make sure that, tastes exactly how we want it to. And then we pull the hops out after we drop the temp and do another crash.
Okay.
We leave that at the crash temp for 72 hours to get the sedimentation at the fermenter side. And then we rely on the pump, a special pump, like a lobe kind of style pump, to convey it from the cellar over here to this, centrifugation
For
skid.
sure.
So we've tried it both ways.
That's wild.
Keep it in suspension, wait,
Yeah.
blah, 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 So pretty cool. Behind us is the CIP skid that we picked up at auction.
Okay.
A bunch of CIP skids.
Yeah.
You got to clean
Yeah, you
everything.
need 'em.
Everything's got to be beer clean, right?
Okay, so that's right up behind us is another skid here.
Yeah. And actually one's cold caustic and one's hot caustic. So all process lines are getting cleaned with hot caustic. All the tanks are being cleaned with cold caustic. That way you're not heating up and cooling the fermenters. You can just move
What do the metrics on that look like? Because I know, like, you talk about time, temperature, chemical concentration, and flow rate when you're talking about CIP.
Yeah.
So if you are running at a lower temperature, do you have to increase concentration? Is that the metric that changes there?
Yeah. So it's called Center Circle, right? That's the chemist, I guess, that came up with it. Center Circle is, exactly what you said. Time. So we're cleaning our fermenters, let's say 45 minutes. Before this CIP skid existed. 45 minutes, 135 degrees with a chemical concentration of like 32 millisiemen per centimeter, and mechanical action. That's the one thing that we didn't talk about. Time, temperature, chemical concentration, mechanical action. The spray ball is inside. You need that spray ball to actually blast the interior of the fermenter and knock it loose. So if you change any one of those parameters, you kind of need to make it up. So the cold caustic is much colder than 135, but the chemical concentration goes way up, right? So instead of 32 millisiemen per centimeter, it's 80 millisiemen per centimeter, right?
Is it linear or not?
No.
That's not, we're just chatting.
That's when you talk to your local sanitation company that provides all the chemicals for you, and you ask them. Or you get on handymath.com, I believe it shows the chemical concentration. Literally.
Well, I always say you don't have to know it all. It does help to know how to access information.
Right.
Though, right?
I bought the most boring book in the world. It's all about CIP from MBA.
Oh, was it the one with Wrench or whatever his name is?
Maybe. Yeah.
There was. I have a hardcover one that's on CIP from MBA.
Yeah. I got the same one. I go, whoa. If only I had this when I first, whatever.
Sure.
You really want to nerd out. Yeah.
All right, sweet man. What are we looking at next?
Well, we did skip another piece of filtration, a true filtration. It's a Crossflow membrane filtration.
Okay.
So what we talked about earlier was just amplifying gravity, but this one is the newest part of the cellar, along with this skid behind me. And this is going off of like porosity. You can't physically actually put these solids through the ceramic or the whatever type style membrane filter cartridge that's inside.
Sure.
Because it's, I think for this stack I said 1 micron. This is 0.45 microns to 0.75 microns. So the product that comes out of it should be microbially stable, right? Because microbes aren't, bacteria, anything that could be in there is not able to pass through. So we can just glance at it real quick. So there's these two sets of membrane. So there's filter elements inside of these. And so
finish real quick.
Yeah.
Is this all attached to that?
Yeah, and these are like buffer tanks. So you can't run dry, right? Okay. So like say the decanter, that's continuous separation, where the liquid will just flow and flow and flow, and the solids will just flow out and flow out and flow out. This is like, you have to keep it all packed with products, and it needs to be vented correctly, and it can't run dry. So you need a buffer tank to make sure that if anything downstream happens, this will never run dry and interrupt the process run.
Sure.
Whereas we can interlock the decanter, interlock the separator, and stop and start kind of at will. These have to be full of product, right?
So these canisters, do they have, is that a cartridge that is loaded in there?
Yeah, I believe it's, they're the stock OEM ones. We've never replaced them because we just got this recently.
Okay.
So I don't know if they're ceramic or some other material. But yeah, very porous, very small porosity, and the newest piece of kit. So it's making the beer clearer than it's ever been, basically, and microbially stable, right?
It looks like there's two heat exchangers here in the center. Why would they be here for this portion of the process? Do you know?
Yeah, because I don't know.
No, it's no problem if you don't. Again, it's new equipment.
Yeah. So. I've never run this. I got to give you a PSA at the beginning.
Sure.
They came with the auction. We installed them. I think in an ideal world we could run this without the buffer tank, but I can't speak to that heat exchanger on the fly without asking Nick Okada.
No worries.
But the crazy part about this is, since it's microbially stable, the cleaning process is like very involved, right? To maintain that, it will abruptly stop the process run to force a clean, because the way you run this is based off the transmembrane pressure. If the transmembrane pressure runs all the way up to like 2.2 bar, it will force a shutdown, make you clean the filters and maintain them, and then you have to press out the product in the run and pick it up later.
Yeah.
So there's a whole big learning curve for us of what products are good to put in here at what time, at what transmembrane pressure.
I would imagine.
Can we complete a run, yada, yada, yada. Because the whole life cycle of the filter element is based on how many times you clean it. So it's kind of involved. It's way above me.
I bet.
Yeah.
I bet.
Large solids coming out of the decanter, and then polishing at the disc stack, and then this is truly micro filtration through a filter element.
Interesting, man.
Yeah. And then behind us is more stuff we bought used. Pretty cool old tank from like the 1950s, whatever. I don't know.
Okay.
It looks out of place to me. But this is just holding deaerated water.
Okay.
So our chemical engineer goes, you need CO2 blanketing, you need another different type of membrane to filter out oxygen, right? So we're just pushing water through these membranes.
Oh, so this has its own system.
Yeah, and so looks like it's not pulling a vacuum, it's at 0 right now, but it'll automatically refill, top itself off, and there's about 1,300, well, it says 427 gallons right there, but that's at that level. It's really 1,300 gallons of deaerated water at less than, one as low as you can go, parts per billion, because this is what's going to come into contact with beer when you're pressing it out through the large pipe vents that we have. You'd lose all this volume moving product to and from tanks, to and from bright tanks, or to and from the filler.
Even the terminology of pressing beer places.
Yeah, push and press, or purge and push. Or, it's pretty cool.
Absolutely.
Yeah, this is one of the first things installed after, once you get a chance. We don't have any sophisticated dry hopping setup in the cellar here because the manway for these fermenter is actually at the bottom, right? So you're not chucking anything in a manway with positive pressure. You're not going all the way to the top to chuck it in, thank God. So what we do is we have these Euro brinks scattered throughout the cellar.
I was wondering, I've seen them
and so that main one with the ladder right there is what we use.
So basically you're going to be filling this with hops, purging it, and then circulating beer through it, I assume?
Yeah, so it's a little bit convoluted, but you can hook up CO2 right here, and you can isolate it so the CO2 is just purging this vessel. Remove the fasteners at the top, pull the manway kind of back, the lid back, and then have your hop set up to throw in. Keep purging the entire time. Close it up, seal it off, and then tighten it down. And then we have product coming to and from the fermenter. So it's one really big loop, and then there's a smaller loop right here where it's coming from the side port into the bottom of the pump, and then coming out of the pump and back into the bottom of the Eurobrink.
Sure.
So you'd run that small local loop on it for like 10-15 minutes just to make sure that it's fluid and it can flow the whole distance to wherever fermenter is that you're hooked up. And it's going to return beer and the hoppy product back to the racking arm. And then the cone of the fermenter is connected to this side port. That side port actually has a racking arm on it.
Yep.
Installed. So when it comes back, it's kind of whirlpooling in the bottom and scooping everything up.
That makes sense.
Yeah. So it's kind of a lo-fi, if you want to call it that way.
I mean, it's a secondary vessel that you can get pellets liquefied and pump back into your tank.
Right. And it's got a spray ball installed.
Yes.
So when you do a cleaning setup, you kind of break everything loose and clean it locally here.
Yep.
And then you can also clean the bigger loop there.
Yeah, that's cool.
There's this Aber perfect pitch. And so the Aber can basically do something really crazy where if you tune the sensor correctly, you can pick up the charge of the cell wall of a yeast cell. And if you do that right, that's above my pay grade understanding. Someone else luckily figured that one out.
You and me both.
You run your yeast from cone to cone through this, and it'll actually pick up and register. So we say start pitching. Cool, we want to pitch Truth. You label your batch. Okay, it's 333. Hit enter. Hit continue. And then it's got a little infographic of your conical fermenter. And it's got a progress bar. And it will literally count the live concentration in the process pipe by that electrical charge. And then it'll also tell you the volume. It's got a totalizer. And then it'll tell you your target, like, okay, we want to pitch 517 million, billion, trillion, yada, yada, yada.
That's so wild,
yeah,
man.
So very cool. And then there's some other craft breweries using this. They also use similar technology in the pharmaceutical industry, but I think brewers kind of picked it up before them, a little more experimental, a little less rigorous.
So really all that's happening is this is just looped in line with the hose from one cone to another.
Right. So it's actually coming in to the top and dropping down and being, it's coming in, the top, flowing past the sensors right here, and it's embedded in like a sight glass component, and then it's going through a flow meter / totalizer.
And so the number that you're running with here, is that a number or some sort of factor based on yeast health and density and everything like that?
Yeah, so after we pitch, we're going to take a sample of the fermenter of one turn knocked out and then run a viability on that to triple check. But we've run hundreds of thousands through here. We have a whole database of all the data collected, and we can harvest that info straight from it as well, and just graph it all out. But it's the basics of Play-Doh times your the volume of your batch times a multiplier for high gravity or this, that, or whatever, and pretty straightforward. With all the crazy science happening in the back.
That is wild. I've not seen that before.
Yeah. That's Todd. Hello, sir. Howdy.
All the cans.
Yep.
Cans and cans.
Yep. Looks like they're doing a cleaning cycle right now.
Okay.
So we have hot liquor delivered from our HLT over to this side of the building to like nuke the seamer. So this is a cool monoblock filler design where we got a 24 head CFT with a 5, I don't know how they talk about, 5 seamer head.
Okay.
And then automation out the wazoo.
Sure.
Basically depalletizer, takes it up, does it level by level, can separate the sheets and the frame, and then it kicks out the empty pallet. We went from sanitizing to like a PAA sanitizer to ionized air. So there's no residual sanitizer in there. There's no funkiness. There's no changing it out and running out of Sani mid-run.
How long have you been running that?
Quite a while.
That's
for
nice.
Years. Yeah, I think that was
Very
a nice little upgrade.
Can I go up there?
Yeah, definitely.
Okay. Sometimes it's just interesting to see the vantage point too. Okay, so decal station right here. So this reminds me some of what we were looking at with Warped Wing when I was with them.
Yeah.
And then we're going over here, file down. Now what does that do? What does that wheel do? Does it just...
I think that indexes it to make sure that you...
Oh, I see.
Actually, this is newer than I've been up here.
That's no big deal.
Yeah. So this looks like can coder.
Oh, so you go all the way over there.
Yeah, we're off the rails. So this is the can coder. So to make sure that you hit every one of them, it's got to index it and time it.
Yeah,
this is before, this is after. I'm just going to not put them back on the line.
That makes sense. And then we're tracking down into the
can
filler
coder
right here. And it just looks like completely full of steam right now.
Yeah.
Is that the unit that is doing the canning itself?
Yeah, so the filler is the large one, and then the steamer is right off the back side of it, a smaller kind of rectangle. And so it's got that top so that you can actually push and make sure there's positive pressure, so no particulates, nothing can get in there when you're actually trying to fill the can. Because right now, they're open to the atmosphere, right? Then it goes through the sterilizing or sanitizing step with the ionized air injection to blow out anything, right? Then it's covered up. Then it enters the filler. That's when you're putting in liquid, right? Yeah. And you're doing that in a positive, or not positive pressure, but counter pressure filler, right? Not overflowing. It's actually making a connection to the filler, and it's purging each individual can, right? So there's an actual recipe in the HMI to fill each can perfectly, right? So as it goes around in the trolley, it's doing different functions, right? First purge, then fill, then cap on foam kind of deal. You know, you put the lid on there. There's a bubble breaker that happens right before the lid is placed on top. So blasting it with hot liquors just to make sure everything's clean and sanitized, sterile. As much as it can be. Right?
Well, sweet.
Yeah. So wild downstream stuff, can't really talk about it.
For sure.
Like it's all been upgraded since I was on the canning line, like, you know, a long time ago. No.
Well, that's cool. And then where are you kegging from here? Is kegging going on nearby?
So products coming in right through these black lines. There's like a bag filtration right before the filter. But if we follow down this direction,
and this was the first time I had seen one of these.
Yeah, this is
because we had one at Sonder, one of the lifts.
Right. Oh yeah.
With one of the vacuum lifts.
Yeah, and then it's basically inlet side, and then onto a walking conveyor, where each station it's, you know, rinsing, purging, cleaning the outside, and then finally filling.
Sure. So dirty kegs go on here.
Yep.
dirty kegs go on here, and then our run through. That's wild. And then a clean. And that's steam sterilized as well, I'm assuming?
Correct. Yeah. It can do
That's
caustic and acid wash. It can wash the outside. On the back side of this skid are 3 or 4 little reservoirs for rinsing caustic and acid.
Sure.
And then, steam sterilization.
That's crazy.
Steam sanitizer.
That is crazy. And what is this guy?
That's so you can place a pallet down there, go right from your lifter, drop on the full keg onto a pallet, and then wrap it. And then have a forklift come up and just take it right to the cold box. So you just follow the beer down here.
Sometimes when you see this stuff, you're like, oh, this is what it's like to be, you know, from the country, from the sticks, and then go to New York City for the first time. And you're like,
whoa.
What is this?
Yeah. You go, whoa. So now the finished product, this is obviously, you see right away, we're storing a lot of hops.
Yeah.
So this is where we're grabbing all the dry hops, all the kettle additions, and then finished product is right over here on the left side. So the canning line, we didn't trace downstream in the filler at all, but it ends up right here in the cold box. It gets palletized, rolls right in here. Forklift driver comes behind us, scoops it up, labels it one last time, double checks the batch number, and then places it to be picked up by semi and taken out to its new home. Yeah.
That is pretty sweet, man.
Very cool.
That is pretty sweet.
Yeah, buddy.
Well, what else, man?
This is where I like to hang out. It's nice and cool. And get contemplative. I just like to cut things open and throw them out. You know, make sure it's nice and clean.
Sure.
Watch out for Stephanie. Hello. So these came in today. So my main goal in life is to make sure we do first in, first out for any and all products.
Sure.
So these are Citra Cryo, and they'll get added to the pallet back there. But I just want to make sure they're not damaged and get rid of the freight packaging, and then we'll clear this aisle and get some more new stuff.